Okay, the situations are given. Okay, small instances. So first one, to find how much a cylinder can hold, volume, or it can refer to capacity also, because holding something, how much water it can hold. If that is the thing, then it will come to capacity, because they are interconnected. Volume and capacity are both interrelated and they are closely related to one another. So we cannot neglect. So we can say that it is volume. Second one, number of cement bags required to plaster it. See, cement bags to cover, that is just to cover the surface. So maybe inner or outer, whichever. So we are covering using something material which is something like cloth or plastic. Then it refers to surface area. Clear? So you can just write surface area, which indirectly means total surface area, because they have not specifically told either full or topless, nothing is told. So you can write surface area. Third one, to find the number of smaller tanks that can be filled with water from it. Volume. Yes. So it can refer to somewhere, sometimes capacity also. So now I come to this back once again. See, observe, this is a small cube, right? Which can be resembling to a dice. Correct? Now I have this cube, whatever I said, which I am holding in my hand. I want to put this into that. How many will fill? How many such dices I can put into the one which I am holding now? 1000, because this is 1 c cubic centimeter. Correct? No. So this one is 1000. So exactly 1000 dice I can fix properly within that cube without leaving any space. So if everything is put inside, this will take or hold such small 1000 dice. Now if I come to this, 10 lakh such small dice can be filled up in the overhead tank which can hold 1000 liter water. Can you visualize that? Correct? Okay. Now instead of that, instead of filling this kind of cube I am going like overhead the tank I will go and I will fill this kind of cube in that. How many will fill? Instead of this 1 centimeter cube dice, I am filling this 1000 cubic centimeter, whatever I could, 10 centimeter edge to cube is there. No? I said I am holding it 10 centimeter edge to cube. Now this cube I will go and put it into the overhead tank which is 1000 liter capacity. How many such this kind of cube I can fill in that, in this 1000? Yes, because divide this by this. Correct? No? Clear? Understood? No? So because this is bigger, 1000 times this, of course it is 1000 times lesser. Otherwise I should fill 10 lakh dice. Now I can just fill 1000 bigger dice. It's not dice, it's a bigger cube. Maybe it is this size, not even this size. 10 centimeter is smaller than that. 1 liter holding. 1 liter into 1000, obviously, correct? No. 1 liter capacity, 1000 times I should be able to place. We can imagine such kind of tank, isn't it, where I am placing all cubes inside and it will get filled exactly. So that is the interconversion, we should remember. So when from here to here, how to multiply, that it's understood because it is volume, 3 times it comes. Correct? No, other direction you said you did not understand. Now you understood that? Because that pictorial representation, it remains in mind always. Okay, moving ahead. Second question is unique. Before going to second question, I would like to ask you a question like, if there is A4 sheet, any A4 sheet, imagine this is a A4 sheet, same paper, I am folding once like this and I am finding its volume, and like this I am finding its volume. Which one has more volume? This one. I want reason. Paper is saying, he told the answer directly. Okay, let us try to understand what he told. Now the same paper, you imagine this is 14, this is 7. Okay, now this is 14, this is 7. Ulta. This one like this I am folding. This one like this I am folding. Okay. So this one is volume more. Reason is, what is the formula for volume? Pi r square h. Correct? No. In this squaring comes for which one? R. So pi into r into h. Online students, you are able to see what I have written?
Yes, ma'am.
Pi
Yes, ma'am.
r into h. So here also pi into r into h. Pi is same. It won't make much difference because pi is same. There is also it is there. Here also it is there. Correct? No. Now here r is 7. Not 7. But imagine it is not 14. 2 pi r is 14. It is not that question which is given in the textbook. It is different. I told before once you try this. 2 pi r is 14. So r may be 14 by 2 pi. Or 7 by pi. How many agree it is 7 by pi? In mind when I see this it is 7 by pi, no? R is 7 by pi. What about here? R is how much? R is 3.5 by pi l. You will get that. Because 2 pi r is 7. 2r into pi is 7. So I will take cancel. So 3.5 by pi. So whatever it is, here r is half of, here double. Correct? No. Here whatever this length is doubled here. In this case, here r is small. R is half the times than this. Correct? No. Or if I just take that as standard radius, this is double. So radius doubled means it is coming in twice it comes in formula. So squaring, exponential growth, something like compound interest, exponentially growing because 2 times it is multiplied to itself. So if I double radius, then almost it is 4 times. Area will be 4 times. Here r is 2 means here r is 4. So here 4 with 4 fours are comes. There 2 twos are comes. So it is area becomes 4 times more. That is why area comes in formula also. R into R comes, no? So it comes in volume. So volume also is more. This is nothing. Even if that height is 14, it is not going to matter because here double times R is doubled. So 4 times more, and this is 7 and 14, only 2 difference is there. Here 4 times already radius increased. So that is why volume is more in this. Now I want real life example. I must already did I say about water tank being always in the shape of, this is the water tank shape. We normally see one considerable height only. We never see which is very tall and narrow. Syntax water tank. We see short and stout. This is the real life application. How do you compare? Like, how do you say? How do you justify it as real life? Why do they do that?
So that their water can, so that the tank can contain more water.
The tank can hold more water. Moreover, I used the same paper in these two cases. The material which is used to make the tank, fiber material. Fiber is good quality fiber. That too, like it is drinking water also, right? We use for domestic purpose. So the fiber should be good quality. Water tank material should be good quality because we consume it. Whatever water saved in that, we consume. So it is good quality fiber. Also it should be heat resistant because it is there in the hot sun. So material really good quality, it is costly. So the producers can produce more number of tanks in less fiber. Correct? No. If somebody is selling like 1000 liter tanks and he is spending so much on the fiber, whichever is fiber body, that material only will be costly. No. How he will make it consumer friendly? And also it should be holding more water. So that is why we go for short and stout. One more is there application in idli. Kedige kadubu. How many have tasted that? In Udupi, like whenever Paryaya or whenever this Krishna Janmashtami is there, it is made one kadubu. Kadubu tililva. Idli.
Yes,
A kind
ma'am.
of idli flavored. Online alidavri gottunda.
Yes, ma'am. It will be done
Only
in banana leaf, covered in
only
banana leaf.
a kind of leaf
Yes,
is
ma'am.
surrounding that
Yes,
idli and it will be tall. And why it is tall there? ಯಾಕದು tall ಇರಬೇಕು? Less volume, why? More of batter it can hold, I can cook faster. That's not the reason. Correct? Yes, sir. Correct. Exactly. More leaf will come in contact with the batter. Say I am just using 2 spoons of 2 big tablespoons of idli batter, but the more leaf will come in contact with that batter and it will give a good fragrance or good smell to the idli. That is the purpose. Though say I don't have much leaf, then I can do the ulta, but the purpose is not served because as like diameter increases for the cylinder, that fragrance will be less, isn't it? It is like not in contact with the batter. That is the reason. Also, how many are very familiar with the this hay baihullu hay, this one stalks? Yeah. They make one stalk shape for summer. During summer, they normally dry this after cutting or after removing the paddy from that. During harvesting, I think you have seen that baihullu is preserved for monsoon. Cattle, it's feed, no? So it should be preserved. So during preserving, have you seen how do they preserve? Either they make cylindrical shape and it is last one protection is there on the top, but the cylindrical this one shape, it is wide and it allows very less contact with the external moisture. It's not entering moisture to this environmental other factors, water or anything, breeze to enter, and it won't get spoiled. It will be dry. That's a very good idea. And then preserving paddy for a long time, batta. That is also, you have seen kanaja, a kind of storing, this one is there, which is made up of normally wood or something also is used. But it is a huge thing which is sometimes cylindrical shape and they make it sometimes for more contact if they need, they will make it tall and narrow. Because more of the contact, thick material should be in contact. Otherwise, they may make it wide. So you just explore this idea. It is real life application of volume and surface area of cylinders. Very beautifully it is. Like when we see, we understand. So try this, make this and try to find out. These two have now LSA same. Not the question which is given in the textbook. It is not. Because they have given here, not the width same. They have told already radius, diameter same, interchanged. So that question and this one is not same. But students who wanted to explore, I gave them this idea. You take this as 14, this as 7. And that as like interchange and find out what is the volume. And try to find out when can the volume be equal. Can anyone guess? If I don't want the difference between the volumes, like if folded like this also or like this also, I should get equal volume.
When they both are square.
Yes, sir. It should be. Somebody already said it should be square. There is no other go. I should use a squared paper so that I can fold like this also, like this also. In that case, 2 pi r is equal to h. And you explore something, you will come to know something else. How it is, like how it is possible. When 2 pi r becomes h, what is the condition? Explore the formula. Then come to me, I will tell. I am not going to reveal more than that.
a doubt
Yes, tell.
that, ma'am, when we are counting the volume
Hmm.
of a cylindrical bottle, if we consider, we
Huh.
want the capacity of water which can be stored in the particular water bottle.
Yes, sir.
So then the water bottle thickness also we should include, or because it will
Uh,
have.
this is we are not considering the thickness actually. What is in interior space only we are saying. Not considering what is, say for example now 1000 liter tank I said no. I am not considering the volume of the cement. Both I can calculate. If I go overhead tank and there is observe, like it is filled, imagine it is filled with water. Then say it is 1000 liter. Then I can say that its capacity is 1000 liter. Its volume is 1000 cubic, or sorry, 1 cubic meter. Then I can, these two things are very clear. But you may think external, like including it the cement material, it is having so much thick now. So that material's volume is different. It is called pipe, or it is the tank volume, or tank's cement volume. What is it made up of? Volume of the material of the tank. It is not what is capacity or volume of the tank. Understood. So you need to see the situation how it is given. Is it empty, or they are speaking about the materials volume? If it is materials volume, the tank is imagined that it is not having anything, or maybe what is it made up of? That volume of the cement they will say. What is the volume of the cement used for making the tank? Then you are using that whatever I explained, no, that cylinders idea. External cuboid volume minus internal cuboid volume, because external cylinder minus internal cylinder gives volume of the pipe. Other day I explained. Similarly, external, like outermost cuboid, and inner there is smaller cuboid, that minus one minus the other will give volume of the cement. Is it clear now?
Yes,
On
ma'am.
time? Okay. So moving to that second question, you can see the picture. It is not like this, because here 2 pi r is fixed. There it is not like that. There the figure is different. They have given the radius interchange, height and radius interchange. We have to calculate LSA also, volume also, and find out how much it is different. Let us do that. But it is such a good exploring area. Can you see that example 10 and 11 students just above the exercise in the textbook? Example 10 and 11, those who want to explore can use those two. What you have to do is, first try to understand what is given there. For example 11 is given as the width becomes the height, because it is folded along the that it is given a rectangular piece of paper. 11 into 4 is the dimension, and without overlapping it is folded to make a cylinder of height 4. So now you make length of the paper becomes the perimeter. Just now, like wide length of the paper becomes perimeter, other one becomes the height. You only for that calculation take a pencil, and at home you do it ulta. Then tell me how the calculation is. Okay, so that gives a kind of exploring idea, not for exam purpose. This exam will definitely will not have any kind of such challenging questions, but if you try to do it yourself, you may get some other like extended ideas, which may give you some insights and will give you some real understanding of the concept. So you can try that. Okay, make it ulta, like 2 pi r is 4. 2 pi r is 11 there right now. Okay, so make 2 pi r as 4 and then do the other calculation and find the volume. Similarly, example 10, a rectangular paper of width 14 centimeter. Example 10 is nothing to explore. You can just see that how it is folded, and the calculated volume of the cylinder. Okay, second one. So let us write the dimensions of the cylinder A and B. Cylinder A, they have given the diameter as 7, height as 14. So write radius as 3.5. There itself. We need not calculate again. Of course, you can write d by 2. Another is shorter. This is 7. This is 14. So R is 14 by 2. 7. Okay. Let us calculate first volume. Volume of cylinder A. What is formula? Pi r square into h. Just now we used it. R into r square. Pi is 22 by 7. R is 3.5. You can do. There only 7 by 2 you can insert. So 1s are 2s are 2 1s are 2 11s are. Any doubt in this? Next you have to calculate. What do you get? 11 into 3.5 into 40. 11 into 14, and can even say mind calculation. 11 tens are how much? Oh, sorry, 40 tens are how much? 140. Add 40, 154. 154 into 3.5. So you have to find that. Volume of cylinder B. Same formula. Pi r square h. Pi is 22 by 7. R is 7. 7 again. 14. H is 7. Sorry. So cancel. 22 into 49. Compare both the answers. This comes in thousands, right? 1078. Okay. Cubic centimeter. This one is 539. Okay. Cubic centimeter. Observe, it is double almost. Correct? No? But the paper is not same. Remember, the paper is not same. These are not having LSA same. Same paper is not used. But I asked you to try with the same paper. So that 14 and 7 you fix. 14 is 2 pi r, not radius. There they fixed. Here 14 interchange, no, height and radius, no, height and diameter, sorry. But interchanging the dimension is not like that. Do you understand the difference between, this is same paper, so if I am interchanging, say that this is 14, this is 7, this is 7, this is 14, this is not diameter. There they have given diameter, right? But this is not diameter, this is 2 pi r, this is 2 pi r. Here 7 is 2 pi r. So radius will not be like interchange. This is not like diameter interchange. It is entire circumference only shifted. So now we have to calculate the LSA of each. Not LSA, sorry, TSA. They didn't mention LSA, right? That deals with LSA. Same paper being used deals with LSA fixed, volume different. Where I used now that tank concept. I can use the same material to get more volume if at all, if tank is having like fixed material to compare the volumes. That also, A4 paper also, like using the same paper this way as well as horizontally, fixes the LSA. But this problem doesn't fix LSA. Its LSA is not same because only if that is interchange, LSA will be same. Here it is not so. They have just interchanged the diameter and the height. Correct? No. Correct? No. Understood? It is not diameter, it is circumference interchanging. height and circumference interchanging when I use the same paper. So to have LSA same LSA, I should interchange the circumference and the height. LSA same, but here interchanging of circumference happens, not diameter. Okay. So let me do that area calculation. Here area will be different because interchanging is not happening in 2 pi r and h. What is TSA of cylinder? This cylinder 2 pi r into r plus h. Formula should come spontaneously. 2 into pi into r is 3 and a half. R plus h is 3 and a half plus h. 2 pi r square. Full no, TSA no. Correct no? So how do we arrive at this? 2 pi r h plus 2 pi r square. Pi r square plus pi r square. This and this 2. 2 pi r is base perimeter into height LSA. So take out 2 pi r plus h. Forgot? We have done this now. This is TSA. So now 1s are 2s are. Can I cancel this also?
No.
No. That is often seen in papers. Don't do that. This and this can be cancelled. 22 into 17 and half. This you calculate. Next, similarly of TSA of this we should do. TSA of B, cylinder B, 2 pi r into r plus h, 2 into 22 by 7 into what is r? R change, 7. R plus h, 7 plus 7. Correct no? 7 and 7 cancels. 44 into 49. Sorry, 14. Adding, no? So you can calculate these two. Okay, but do calculate and compare. Which one is having more? B. Okay. Both volume and area more. But even if you keep area as constant by interchanging circumference and height, you will come to know that volume is more for short and wide. Okay. Good, I got that answer that if it is a square, it will be volume same. Because that is the only situation, otherwise we cannot make it equal. Third question, I leave it as homework. Find the height of the cuboid whose base area is 180 and volume is 900. One more question. Can anyone guess? Base area into height is volume. It goes back to basics, what we studied. Base area into height. If they don't give any idea about base dimension, but directly base area is given, into height will give volume. So volume by area will give height. But unit should be same. Check that. Is it same? Yes. So it is correct. Third one. Correct, no? Centimeter square is same. Yeah. Online students, any doubt in third one?
No, ma'am.
No. Now, let me just start with the fourth one. I am not solving it today. How to do it? A cuboid is of dimensions given 60, 54.
Ma'am,
Huh.
there we have to find out the volume of cuboid
Both, yes, sir.
and then volume of one single cube.
Yes. It is something like if a cuboid is there, it is made up of wax. Imagine small children making wax, using wax for making the solids. If a child is making cuboid, it has used so much of this one, clay or anything which is a material which is moldable. Now, how many such can be made, how many smaller cubes can be made using the same clay? If I ask, then we find the required volume and we divide how many can be there, like that. So here now we are going to find how many can be filled. So how many small cubes which side can be placed? Placing also is like that only. So only I said that small centimeter cube I can place it inside the one which is 1 liter capacity, and such 1 liter also I can place inside 1000 liter capacity, or the small dice also I can place. So it is just dividing. That formula if you understand, then you will understand this easily. Find the volume of each one. First find cuboid, then find the cube, then divide one by the other. Because how many such areas are there in this is the question. Any doubt till now whatever is done?
No, ma'am.
I may do that fourth one in the next class once again on board. Be ready. Just writing part. How do we write? That statement has to be written. Volume of the cuboid, dimension of the cuboid, whatever. Then the volume of the cube, 1 divided by the other. Number of cubes that can fit into. That is only the minimum required thing. So in the next online class, when I am taking constructions, be ready with at least some of the instruments. So at least where to hold, if you can understand. You can do the rough part in some practicing book, and actual correct one you can do in notebook later. Because as a, like, even if I as a teacher or as a student, I may not be able to say that you have to do it online. It is not possible. When I am teaching, I may not be able to draw parallelly. It is not possible. Writing only is tough. Isn't it? Yesterday students told, if I say make you compel, write whatever I am doing here, is it okay? Like, but it is not possible because they also told it is not possible, teacher. Because I have either phone, even if laptop is there, by the time I just put my vision into book from the laptop screen, something is disconnected. I don't know, like what teacher is telling, I cannot make out next because teacher is explaining, no steps. Blank means it is, we are not sure whether we are online properly or something is happening, we don't know. So that kind of not connectivity is there. Now you may have to go through 6 standards angle constructions. What is angle construction? Not drawing, construction.
90 to 45 degree.
We construct angles without using the protractor. Do you remember? One easy idea I will give to understand construction. Okay. So if I have to bisect this, what I do?
Take a midpoint.
One typical word is there, bisection, more than half. Do you remember? More than half of the given line segment. So I draw more than half, almost I take and I draw an arc. And same, without changing, I from here I draw and this I join, so I get bisection as well as bisection will be perpendicular.
Ma'am,
Correct now?
to 90 degree, like making a semicircle and cutting the semicircle into 2 halves.
But the secret behind that many don't know. So this is line segment bisection. If angle is like this, to bisect this, first I have to draw an arc. Because I have to see the angle, I should draw an arc. I see the arc, then this is the angle. Somewhere I can see this as the angle, because that is the one which is deciding what is the size of the angle. Now how did I start in that line segment? Same way I should start, I should take these two as end points and take more than half, and I can draw an full arc only. I need not limit only upside. So I can draw an arc. Without changing what I did here, that more than half only, I do here also. No changing, of course, whatever more than half I do. Then I should draw. Then this is called angle bisector. Correct. Next, how many of you know How to construct 60° without protractor? 60°. Yes, Ishan, tell me.
Ma'am, you draw like this, right? Take the protractor, draw art.
Protractor.
I was like the compass.
Compass. Then here.
Yeah, do that.
Which radius?
I mean, what radius?
Any radius. Okay, 1 arc.
From that point where.
From this point, again cut with the same radius.
Yeah, with the same radius.
What is the intention?
Equilateral triangle.
Yes, equilateral triangle. I told you last year, do you remember? One student also in the other class did not say how to construct 60°, except Abhima, because that is the difference between how we teach here in India and how in abroad they teach. They are very good at like getting the concepts, may not be that good in writing. But I understand that this is an equilateral triangle. Isn't it? What we have done is indirectly one equilateral triangle. So I fixed its radius. Free to choose any radius. Because all equilateral triangles will have 60° angle guaranteed, no? So I can choose any radius and I have cut this. Now I fix another side and I made this say x centimeter 60° and this is x centimeter. So now it is all 60° I got because this is obviously radius. So indirectly I got equilateral triangle. So that if I remember. Now bisection means more than half. This is the angle or this whichever. Now keep these two as reference. Take more than half. One arc you draw. From here, draw another arc. Cut. You will get. I don't know. This is not proper. So cut. You will get. Yes. That is again due to another beautiful concept, bisection. You know two equal circle with two equal radii. They will touch each other. If the center is joined, if radius, they will touch each other. Radius same. Correct, no? If I increase the radius, what happens? They will crisscross. Correct, no? If I don't draw in such a way that they touch. If I just with the same radius, one circle I draw like this, and another circle I draw like this. Now the distance between this center and this center is now same. Say fix it, not R. Of course not R. If I fix it, then this will be 90°. It is always true. Even if I increase the radius and I draw one circle, and from this, without changing, if I draw another circle, see, this will come like this. So it is playing with circles actually. And the same idea is used in bisection. It is bisection of the bisection means I said no, draw full circle. You need not actually draw. If this is to be cut into two equal parts, from here draw a circle. But take more than half. Slightly. The reason I will tell. With the same radius, draw another circle from there. They are identical circles. Now this one is bisection. Because more than half I took, they are not just touching. They are intersecting. They are cutting each other. So that is the beauty of that. Bisection's beauty. By bisecting, I made them like cut each other, and when I join that point, it will be perpendicular. Bisector. Clear? Okay. So there is something more actually. We can explore whenever possible. But you study what is the method of construction yourself. Then easy way to reach that I will tell. Students online, it is time, so I am disconnecting.
Okay, ma'am.
Bye.